welcome to Quantum Kinetics First Diffusion, Season 2, Episode 4. I'm here with
Randal Bird, the President and Chief Operating Officer of Quantum Kinetics Corporation.
It's great to have you back, Randall. So what are we going to be talking about today?
All right. Well, we've got a few things we're going to cover today, and a couple of them are familiar and a couple of them are new. So we're going to have a little variety today. But first, I wanted to go through and make a couple of thank yous, because it's really been fun to watch how our episodes have continued to grow the channel. That means people are interested. Well, they should be. We've got a lot of great content today and what's coming down the road. But we are almost at the threshold of 300,000 subscribers.
Yes, it's kind of amazing. Thank you so much for subscribing.
Wow.
And checking into the YouTube channel here with Quantum Kinetics Corporation. We're so happy to explain and show you guys what safe cold nuclear fusion with the arc reactor technology looks like.
Right. And so I also wanted to recognize what a terrific episode that was with Brighton. You guys, Gravity, and just so much that you covered. Yep. Any reflection on that now that we're kind of moving into this?
Probably should have had a little bit of a drink.
Oh,
Well, there you go. Thanks for coming on the show.
Hey, good to be here. And cheers. We got a little screwball today.
Boy, that is smooth.
Very, very. It's delicious.
Smooth like cold nuclear fusion.
Like dangerous, except the nuclear fusion is safe. But we also have a couple of things that I wanted to bring up. We have started the process of getting our teaser and then a little bit of a taster, I guess, of our upcoming documentary. And I have to say, we used some of the video clips from an episode that we had published and aired over Bloomberg Network. And this is going to be really good. I have to say, I've seen the preview and I've seen a little bit of the extra that's been put together. The production team over there, that guy
we also have Jason as the art director helping out as well. So it's a team collaborative effort.
It is. I am just over the moon that we're really getting something quite special put together. You will love it. We've advertised it as coming out in December. It could be earlier if all the ducks fall in a row. Maybe
during Thanksgiving.
Yes, so hang on for that. This is going to be a very comprehensive expose, and I think everybody will appreciate the journey. So in reflection to that, we are taking this episode to share a little bit of the story that will give some detail and a little bit more underneath of what happened to get to the documentary. So you're kind of getting a little glimpse, but really this is some of the stuff that is the firmament underneath it.
Oh yeah. There's here. So we have to talk about that. We have a book out right now, and it's a full color laminated, The Discovery of Cold Nuclear Fusion. You guys can check it out at Barnes & Noble. It's 306 pages. It's a quick read, and there's pictures in there too. So you can kind of go along for the detailed journey into the Chronicles, and you can go with us into the national labs and also industry labs as well. So it's just a really good blanket understanding of the story. And then the documentary that comes out in November or December will just be the icing all over that cake. So you guys should check out the book for sure and get yourself ready for that documentary.
Right. And we want to say a special thank you to Riley Lee, our Chief Financial Officer, and he has been the author of these, the Chronicles, the 2 books, and is writing our 3rd. And let me tell you, we don't have a lot of work to do to write that. This story just writes itself. He's actually being more of a reporter that's gathering the info. But honestly, this has been such quite a journey and quite a ride.
Well, you remember, this is like basically the farthest that cold nuclear fusion has ever gotten in history, like human history. So like every email that comes in or every event that occurs or email we get from our lawyers, it's like basically the first time ever this has happened. So we're going into a new territory here.
It is. Again, kudos to Riley Lee for getting this pulled together and continuing to do terrific work for Quantum Kinetics. All right, so we're going to get into some of the details, and I'd like to share personally that when I met McKane, I had a little bit of exposure to this from him telling me the story. And this was before after the first book came out, but before I got my hands on it.
Mm-hmm.
So listening to it from a personal touch gave me a real appreciation for that first book. But this also gave me an appreciation for what McKane had been through to get to this point today. So we're going to drill in a little bit.
Okay.
And so it begins with you're living an ordinary life. You have a business. You've got a successful...
I was in the Matrix.
You were in the Matrix and significant in the Matrix, right? And so this was one of those things where it was a dark and stormy night. It was not quite that, but it was close. And so
it was.
Take us through a little bit of this accident and, kind of briefly.
Yeah, real quick. Just got caught in the snow out in Leavenworth off a logging road and was hanging out with some friends. And we just lost control of the Subaru and we went down the logging road, basically hillside. And it was over 230 feet down and we cartwheeled 12 times in the Subaru. And I mean, we were like doing cartwheels, and the rooftop was getting smaller and smaller every turn. And I remember thinking, Randall, that, I was counting the turns, like 1, oh shoot, 2, oh crap, 3, oh, we're getting faster, oh no. And there was a moment there where I was like, well, the momentum is picking up, the inertia is going faster, the roof is getting smaller. And I kind of just accepted that I was going to die. Like it was like being in a wash machine, but was getting smaller.
Yeah.
And that, once we stopped and we landed upside down, it was like very surreal because we're just hanging from the seats.
Yeah.
And there was no sounds anymore. It was quiet. There was screaming, there was glass breaking, there was wood breaking, there were trees falling, and then silence. And so when we got out of the car, and it was snowing like crazy, and everyone was in shock. No one said a thing. And then this whisper, thing hit me in the forehead, and I saw this vision of this thing. And I heard the whisper in my head go, hey, you almost just died and you didn't do the one thing we sent you here to do. And so when I had that moment, I realized my life is going to change.
Right. And so that was the beginning of an end and beginning of a new beginning. And so along the way, you started to get into exploring what that calling, I guess this is a calling, and it started to take a hold of your life, not just a hobby level, but since you had it as a sense of a calling, this became an absorption.
Yeah.
And you began to engage this in a way that was a little bit more like, honey, you're cleaning out the garage and it's not for getting more tools. It's for putting this stuff in here. What's going on? What was that like, going through a transition, this metamorphosis of losing so much from that life that you almost did lose to starting this new one? Well,
I mean, like what you said about the garage, I would just start hoarding things in the garage. I'd go on eBay and buy circuits and play with them and just was surveying and playing with electrolysis and being like, hey, I can put that in my car. And then my hobby became almost like an obsession.
Mm-hmm.
And then my wife at the time noticed, and everyone my friends noticed, and they're like, is he okay? Is he he's kind of... And then things just unraveled super quick because then I had to move back home and I sold my business and then we got a divorce and all the stuff. So my whole life basically, again, went down another mountain. So at that point, I'd basically pulled the Matrix gizzard thing out of my head, in the movie.
Right.
And I'm choking and I'm awake now. But now I'm in a new space where it's truth is stranger than fiction. Nothing really makes any sense. Up is up, or up is down, and down is up. And I'm trying to figure out how to make this thing work. And I've been reading all these textbooks and it wasn't working. It just was not working based on all the studies I had done. And I was alone in the shop. My friends had left me. My family thought I went crazy, which it probably looked like from afar.
Mm-hmm.
Right.
Mm-hmm.
And then all of a sudden I kind of had a moment again in the lab all by myself and I had that vision come back, that voice, that whisper say, hey, don't be depressed. Don't be sad. Don't kill yourself. You're almost there. Just do this one thing like this. And as soon as I saw it, I was like, there's just no way that's going to be possible. That conventional electronics doesn't work that way. Well, I have nothing to lose. I might as well try it, right?
Yes.
And so I went and configured everything. It felt like an out-of-body experience. And then I plugged everything in and turned the knob, and there was all this hydrogen oxygen gas coming off. And then all of a sudden it was like, wait a minute, how come the power's so low? I've never seen it so low before. What's going on? And I actually, after I did that, I started getting a little mild, like nausea. I was like, I don't feel so good. I better go take a nap. And so then I'd like take a nap in the middle of the day, and I'd come back and play with it again. And it just kept doing that. And I was like, wait a minute, there's something really special about this.
Yeah.
So, and then we were like, well, we all made it, like the family, like my parents and I, we all made a decision. Like, maybe we should go get it researched and get it studied and get it confirmed that we're maybe doing transmutation. Because what we first saw when we turned it on is there was all this particulate matter showing up. It was like basically getting dirty. You're like, why are these black crystalline rocks showing up from ordinary tap water? Like, or a little bit of seawater. What's the deal with these rocks? And what we found when we took these rocks to the University of Washington to have them electron microscope tested and actually sliced in half and polished, and then they had them electron backscatter to find out what's actually this rock is on the outside and the inside. And what we found was that the outside is basically a carbon nitrogen metal, right? Kind of like stainless, but not really. But in the core, it was carbon. Like, it kind of had the consistency of like a planet, like
the building blocks of life, of course, are carbon.
Nitrogen, and oxygen. That would be organic matter, yes. And we found oxygen and carbon in the core. And actually, we had the electrodes. We pulled the electrodes out and had them sliced and also checked, like from the outside of the perimeter to into the center. And sure enough, the outside of the electrode was turning into carbon, while the inside was still stainless or aluminum or whatever.
Right. You had a chance there in the documentary or the Bloomberg appearance to go through and highlight that through the other founders. And this was something that's going to stick in time, and it plants a flag, because this is one of the components that are part of the claims we're making, and again, verified. So let's take that and kind of put that and log that one, and then let's carry on.
Well, it's actually really interesting, Randall, because during a fission event, which is a nuclear fission, so say you have like uranium, it's really heavy, as it's like decaying down through time, like 400 million years and whatever, it's starting to turn into tungsten, it's starting to turn into thorium, it's starting to turn into lead. It's going back down the periodic table, and that's fission. And then in nuclear fusion, we notice that it's doing both. Like, we're going up the chain, like hydrogen, deuterium, carbon, nitrogen, oxygen, and then it gets to iron. And then it just, everything that's in the reactor, that's in the, fusion on demand, cold nuclear fusion arc reactor, it turns everything into carbon, nitrogen, oxygen, and iron. And it's just this dense magnetic thing. It actually becomes magnetic. It's like, what?
So next that brought taking this new pearl of great value kind of a thing, and beginning the investigations, and without naming names, I don't know if we can anymore.
It would be safe not to mention any names.
But we did, at that point, you've taken off, and you'll find this in the book as well, but you've taken this to a couple of places, had it investigated, because it still wasn't determined quite yet to be true fusion. It was more something is happening that's transmutating it, and the realization hadn't quite taken place that it was fusion.
Correct. That's a really good observation, because we originally worked with the Department of Energy at PNNL to get these things tested, and that's just a normal contract. Everyone can do that. It's not a normal, it's very normal to get a research done.
You're doing research,
Yeah, we're doing research. And so what happened was we called it electrophysical transmutation based on the data, which, by the way, I had to write the first draft. The original people we were working with in the research study labs, they didn't want to write the manuscript at all. They didn't want to write the first draft. When they saw the data, they were like, this is statistically significant, but we don't want to write it. And I was like, well, what do you mean? You're the scientist. I'm the artist. Why am I writing this?
Well, the anomaly of it, right?
Yeah. And so I was like, well, I will do my best. So I would grab all their data, and I was looking over it for 3-4 months. And I was like, hey, what's going on here? Why'd this one go up? Why'd this one go down? What's going on here? And I was just searching on, other research papers, Google, books, and I just came up with this idea. It's like the electricity going in is super small. There's these exotic X-rays showing up, which is indicative of beta decay. And I was like, okay, well, 1 + 1 = 2. This is electrophysical transmutation. The atoms just rearrange based on the field.
And this is the means, and it doesn't add up because over 400 million years, it takes that long to Earth transmutates it.
Right, because of Earth's gravity and flux and all those vibrations and from the sun's, charged particles and all that. And then when we were like, okay, we're doing electrophysical transmutation, we got it studied and research verified and published in NPJ Nature, which is like awesome. And by the way, the reviewers were like, this is an amazing technology. This is great for the whole world. We need to implement this soon. And then we were like, man, this is awesome. So we were like, what's the next thing we should do? Like, if we did the impossible, what would be the next impossible? And so we were like, well, let's turn radioactive waste into inert stuff. Like, let's try it.
Right. And so these beginnings of investigations took a couple of different directions. One, you made new discoveries, but you also found resistance, being stymied or being rejected or being disavowed as anything that they would recognize. So what were some of that like? I mean, this is literally, you're showing it, they're seeing it, but now somebody or someone, somehow it's being throttled or discarded.
Right. So over the 10 years of basically doing this research and studies, we've met a lot of people along the road, right? We've met people that are like, we don't know what you're talking about. Don't talk to me anymore. We have people who like say, oh, I know what that is and I'm going to steal it. They've actually said that. And then we've had people like, well, we want to do studies with you and find out ourselves. Can you do that? And actually one of the scientists we work with the radioactive waste experiment we did with a national lab or a global lab, they said before we even showed up to do the experiment, we were doing a Zoom call to like get all the parameters ready and all that. And the lady was like, if your device can do synthetic nuclear beta decay on demand and transmutate uranium, that is a Nobel Prize. And I didn't say that. She said that. And I was like, well, let's try it. Yeah. And so everyone in the Zoom call got excited. And then when we showed up, I showed up with Mark the first time, and then the second time we did it with you and Ginny. Like, everyone was just happy to see us. We walked in, and they gave us hugs.
Oh,
it's like, what?
Yeah, the first time you went with Mark, it was like you're a kid with a little science project. And after they saw that, the second time I was there, this was really fun. It was fun to see. From what I heard described, this was really fun to see the difference.
And you can check out the details of that story and what happened when we were in that, doing that research in the book. The details are there, and they're really interesting. Like, first of its kind.
Yeah. So back to being stymied by academics, government, industry. So I only want to touch on it a little bit more because this is a positive message, but yes. I do want to put a bow on what it was that we experienced and have experienced since then a little bit. And then we'll come back to how we invested money in doing our own research. Okay.
Oh, yes. So, it's been a very wild ride. I mean, some people are just super happy. One thing that really stuck out at me, that one of the really heavy duty hitters of one of these companies was like, hey, I looked at your data looks awesome. And by the way, this guy has been doing, nuclear waste, like filtration systems for 30 years plus. Mm-hmm. And he's like, hey, there's only one way to do what you just did there, is a room temperature thermonuclear event. Mm-hmm. And that is the definition. You did it. Like, and to hear someone say that was like, what? Like, we kind of knew, like, we were like, hey, this looks like nuclear fusion and fission. At the same time, and to have someone of that caliber, I mean, this guy he's a guru. And then before he left and had a parting message for us, like not just me, but for us, he said, look, only 1% of the population is going to know what you're doing. Only 1.
It's really less.
It's probably 0.5%. And then he said, unfortunately, of the 0.5% or 1% of those people that know what you just did, half of those people are going to be evil and half of those people are going to be good and try to help you. So he basically patted us on the head and said, good luck.
Yeah, good luck figuring it out, because it's a lot of praying about that. So that is the kind of thing that presents challenges in one area. We also have experienced it through academia. We've also experienced it through industry challenges as well.
Oh, yeah.
To gain acceptance or even be recognized and given any credit. And the suspicion has grown now to where we think the credit is being given, but now if they can't have it or they can't claim it, then they're going to throttle it until they figure out how. And we go back to the Philo Farnsworth and the Tesla examples, and we don't need to dig into those too much, other than to say there's a few components that we're dealing with that look familiar to that story and those stories.
Well, I'll say this, Randall, is that there's a famous saying that time flows like a river and history repeats. So if you're going to predict the future, you better learn the past.
Well, isn't time flowing like a river and it repeats? Isn't that a swirl?
Have you ever seen the movie The Never-Ending Story? It's pretty good.
Yeah.
A lot of parallels.
Including
the Falcor. You're the Falcor. By the way.
Thank you. I'll take that. I've been called worse, and not.
Hey,
Falcor, I'll take that.
He helps. He gets Atreyu to the edge of the borders of Fantasia, so he can actually go and try to save the world.
Falcor's in the house, and going to do everything we can to help this over the line.
Yep.
So we know that we encountered bad actors. You've mentioned a couple. So along the way, you had a direct encounter with an outfit in Texas, and we won't name names or companies, but they flat out had. Just tell briefly about the dinner and then what was said.
Well, it was someone talked and said that we had this technology, one of our people that we know here in Washington, and then they knew friends that knew friends and knew someone, and it just kind of went down the grapevine, and we got basically a call saying, hey, we want to talk to you on Zoom. And I'm like, okay, sure. Can't tell you who they are, but they get on the Zoom, and the guy who gets on says, hey, McKane, I read your patent, and I really am interested in your tech, but I have a couple questions for you. And if you pass these questions and you nail them, I can get you a job in a place that is very special. And I'm not going to say what it is, but very special. I knew exactly what he was talking about. And I was like, I want that job, by the way. You know, I don't have a wife. I don't have kids. I don't own a home. I'm basically homeless, and I just have my technology, our technology, and that's it. So I was excited to answer these questions.
Right.
And he said, okay, does your technology work better in space, or does it work better in an atmosphere? And I sat there and thought about it, and I said, definitely works better in space. And he goes, oh my gosh. And then he's like, okay, well, I'm going to show you another thing. I'm going to show you a picture. And that picture was a picture of the carbon cycle. You know, like you have the ocean and the clouds and then industry and then the cows on the farm and then the carbon cycle, right? Mm-hmm. And I said, oh man, that's so easy. He goes, show me, point to where the big problem is and also the big solution. And I'm like, dude, that is so easy. And I said, it's that big blue thing. And he goes, very good. And he's like, I have one more question for you. I'm like, oh no. You know, I'm getting kind of nervous, like I want to pass this test. And he's like, this company that we have has basically we on the top of the spreadsheet, we know these things that we can do right now. We know they're possible and we can do them right now. On the bottom of the spreadsheet were words that they knew were possible, but they wanted to do it, but didn't know how to do it. And he said, whatever, just read through the words, and any word that pops out at you, just say the word. Now, I'm not going to tell you what the word is because I want to keep it kind of secret, but I said the word because I was looking through. And by the way, there were words I didn't really know because I was an electronics guy and a artist. So these words I didn't really know, but I'll give you a hint. They were biological words. Okay. And I saw one of the words like, oh, I can do that. I do that every time. Like it happens. They're there. And he goes, and he just quickly turns off the screen. And he leans back in his chair and goes, oh my gosh, we've been waiting for you for 35 years. Like, what are you talking about? What? And then he's like, there's a prophecy about you. And I'm like, you're crazy. What are you talking about? He says, look, there's people who know and there's people who don't know. And he says, there will be a boy who is a man who shows up out of nowhere with the big solution. And he's going to change, his technology is going to change the world forever. That's what he said. And then he's basically like, I got to go to another meeting, but this meeting has like gone beyond my expectations, but I got to go. And he just hung up. And I'm like, I did a good job, but he's not going to give me a job now. He just disappears.
Yeah.
But he did mention that he's like, if you don't have $6 million in the bank, I'm going to steal it. He did say that before he left.
Right.
Which I'm like, what are you talking about, man?
Well, he heard the thing you wanted to hear and went to tell headquarters immediately that he's got something going on there.
But I just want to make one last point about that, is that in the end, Randall, if people do start stealing this technology and start making the world better, like for example, like if they find a way to like get rid of PFAS, like forever chemicals using this technology, you know, that's going to make the world a better place. So in the end, ladies and gentlemen, the boat is going.
Yeah.
Cold nuclear fusion is officially here, and you're going to start seeing it.
Well, we've seen other companies angle towards the science that we're talking about and trying to attempt it, because I don't want to beat a dead horse from the many times we've talked about this, but they haven't got further, and they are honestly not going to get further. They're just going to build bigger stuff and attempt to outgrow the problem, but they're still going to face the same basic science. They can't increase the output. They can just do bigger buildings that produce a little bit more because of the size of the scale, not because of the change in the technology.
By the way, you can make nuclear fusion happen at small scales. Actually, matter of fact, we're working on the repulsor hand palm technology that if you can make the nuclear fusion work at that scale, which is basically your palm, you're on your way to like making safe nuclear reactors for homes and everything else.
Oh yeah.
Don't make it bigger, make it smaller.
And make it smart to work with existing systems, and it'll be the avenue to creating new systems that take advantage of this technology probably long before we're gone as well. So let's turn a new direction. So we started investing our own money and doing our own research. We went to these labs. We had in the last year and this year, 2 different independent labs. How much do you want to talk about some of the results that we've found? I think we talked about last year's lab results told us a lot about transmutation and nuclear waste remediation. That was our point of emphasis, and we got a lot of kudos for the 24 hours reducing nuclear waste by 80% verified by an independent lab. And so that should be positive, not frightening to our competitors and the world. That should be an illumination of what we can do, and we're here holding it in our hands.
Yeah, we want to help. Like, we're here to show you that it is actually already here. Like, this is not like it's going to be 10 years from now. It's not going to be 20 years from now. No. It's actually here right now. And you're going to, again, I'm going to say it again, you're going to start seeing these things start populating into the society. But there is a very important point. You have to do it the right way.
Well, right. And it is potentially dangerous if you don't know what you're doing.
Yes. Like, so for example, like nuclear hot fusion companies, they use like 1,000,000 volts and 1,000,000 amps, and they just fire it, bam. And then there's this huge explosion in the reaction, and there's fusion, probability of fusion, yes, but not very good. But if they use the quantum kinetic well, registered trademark, technology and the arc reactor technology with those power energy inputs, all I can tell you is that you should not do that. Whatever you do not think that you know what you're doing, because if you do that, if you're reckless enough to say, I'm going to steal the tech and I'm going to throw 1,000,000 volts and 1,000,000 amps at it and see what happens, bro, ladies, do not do that. Like, I'm just telling you, don't even think about it.
Well, back to the 0.5% that know, even a sliver of those are even going to have the means to start figuring out how to tinker that together.
Yes.
And I'm going to tell you, some of those already exist as other companies.
Yes. Which we don't want to talk about.
And we don't want to talk about that. So moving on. So day one of our milestone project, when that comes, we want to make an announcement to the world. We want to have something special. We're closer, and we have, I mean, our technology is there. We're looking for that partnership still.
Yeah. And Randall, we're probably going to get a partnership relatively soon, honestly, because like historically speaking, like you mentioned with Philo Farnsworth was the kid from Utah that created the vacuum tube that did television for the first time. It was the scanline thing, right? And when he was in Utah as a boy, he would watch the farmland. They were doing the farming in scanline. And so he drew the idea of a television tube on a chalkboard when he was really young.
About 12, yeah, I remember this.
Yeah, and so his teacher was like so perplexed and amazed that he took a picture of it and he held on to it for like, 12, 15 years. And then Philo Farnsworth moved to New York and then like got a $50,000 loan, I think, from a bank. And he and his brother worked on the vacuum tubes and started making these television tubes that he thought would work. And then they started turning on and he's like, oh my gosh, it worked. I got to make another one just to confirm, because that was like insane. So they built another one, turned it on, and it worked just fine. And so they wrote the patent for it. Philo Farnsworth with the patent for the TV. And as soon as he got it, RCA Corporation of America, Radio Corporation of America, sued him. Bam. You're sued over a vacuum tube. And he's like, wait, what? And so the judge looked at the RCA's patent, which was filed before Philo, but they couldn't get it to work. That patent didn't work at all. But RCA had it. And then Philo Farnsworth, a Utah boy, files a patent.
So this is this being fought at that moment in the patent office to recognize whose, or was his given independently?
His was given independently to him by the United States Patent Office, and then RCA found out about it and then sued him.
So the patent office didn't do their research to say we should have stopped that before it got there? Is that what I'm hearing?
Well, you have to understand the patent office, there's lots of different departments of the patent office, different technology, electronics, mechanical, and there's a lot going on. So it's hard to screen everything.
So it was an integration coordination mistake then, that it may have ended up in two buckets.
It's possible, but the point being is that there was a patent granted and then a patent granted earlier by RCA, but it didn't work. And so they went to the judge after the filings and the judge said this: both of these patents look identical, and I'm not smart enough to know the difference between, RCA's patent and Philo Farnsworth's patent. So I'm going to have to give the winnings to, RCA. And then literally the teacher, Philo Farnsworth's teacher had a picture of it when he was 12, and he brought it into the judge and said, actually, he drew this thing when he was 12 or 13 or something, when he was a kid.
Yeah.
And the judge looks at it and goes, that's the patent.
Yeah.
And so the judge ended up giving the winnings and gave it all to Philo Farnsworth. And then as soon as that happened, RCA just bought Philo Farnsworth patent right off of him and said, that's ours now. We're going to give you money. You go away. There it is. And then from that point forward, it's always been RCA was the creator of television. RCA was all that.
Sure. And so we're going to run into a little bit. So like I said, day one of our milestone project is going to draw incredible interest, because it's like, wait a minute, they've actually turned it into a commercial viable entity now. That undermines and threatens everything we know, because it's different than hot fusion, and look what it's doing. That is the way of the future.
Yeah, it's called the getting across the corporate valley of death. Once you get across that bridge, which if you don't get on the right bridge, you won't make it.
Right.
And so there's lots of corporations that try to get over it with their milestones, but then they fall into the pit and die. So in order, like even the big hot fusion companies, they're still trying to get over the corporate valley of death too. Like they still don't have a viable product yet. There is no product yet.
But McKane, they're throwing billions with a at these guys, and it's is it based on the fact they're making promises they can't deliver? I mean, we could get into some hot water with this.
We could speculate, but I don't want to. But all I can tell you is that the influx of money is going to these certain hot fusion companies. Yes, that's fine. But the question is like, when you see something working, why isn't it getting funded? Why isn't it being helped? Why, like, you have to ask yourself, like, what is really going on planet Earth here? Like, we all know we can do better. We want to. I mean, you're an athlete. You want to be a better athlete. You're an oboe player. You want to be the best oboe player or pianist ever. Like, everyone wants to get better.
But you want
What's
to be
going on here?
You want to be the best version of yourself, right? And
Yes.
you may or may not be the best ever, but you just want to do the best version of who you were given, who you are, and what you were given to work with.
Because remember, it's just like an oscillation electron that's vibrating back and forth in the ether. Like, its vibration influences everything around it, and if it's vibrating in the right way, it attracts other matter to it, and then it grows and it gets stronger and it grows and it gets stronger. It's all gravity, man.
So you mentioned earlier about fission and fusion.
Yes.
And I was thinking electronic capture with
X-rays.
discharge.
Yep. Mm-hmm.
Is that our version? Would you call it that because we have mentioned before we do both?
Yes,
and
yes,
is that kind of our secret right there? Is that drops it in and spits it out?
Well, there's just so many mechanisms that happens when you start doing a gravitational flux field that's artificial. Like, you get the compression. Like, when you do a gravity field, you're actually doing high pressure, but it's room temperature high pressure. It's an electrostatic flux and a magnetic flux that's out of phase with the entire universe. It's almost like you've created the well.
So what degree do you believe in factor is greater than Earth's natural gravity? Because this is sucking in greater than gravity, correct?
Yeah, actually what's funny, Randall, is that gravity is one of the weaker of the fields. Like, there's electrostatic field, which is like the E field, positive and negative, and there's a magnetic field, which is north and south. Like, technically gravity, gravity will not show up until you have both those field lines, E field and B field. You have to have both magnetic and electrostatic. Once you show those forces first, then gravity shows up later. It's a secondary fundamental field. It's almost like an echo.
So the E and the B trigger.
Yeah, because they have to cross. Like, there's a certain like bifurcation crossing event that occurs between those field lines. Like, one's going out and one's going around. Like, one is male and one is female, and then when you join them together in a very special way, they do a creation event. They create a baby. They create more mass.
Right. And so transmutation then is the replacement of something, but the question to me is still the magic of how did it become something it is not? We have seen from our results when we do the waste treatment and we look at the variables in our charts.
The source sample has nothing in it.
Has nothing.
Distilled water, nothing in it, except for the radioactive nucleides we put in it.
But how did it get there? I mean, that's the thing. Is
afterwards there's sodium, there's potassium, there's calcium, there's nitrogen, there's like iron, there's copper, there's
tritium.
You have to actually. One of our very first studies we ever did when we were working with the government for our study, our first one, electrophysical transmutation, we actually did do a test on the side to see if the source well water, the tritium level, versus the treated water, and this is an independent test, and we sent it off and had it tested for tritium concentrations, and the source water had more tritium in it, and the treated water had basically no tritium, and it went down by 8% or 9%, which for well water, that's huge. That's like an exponential number. And so what we found is, and I actually have B-roll for this, but when we poured the water out into the plastic container to send to the national lab to have it tested, as we poured it, you could see the water like beating up and like kind of holding its surface pressure and holding and staying like a bubble on the surface, and then it would bloop. Like, it actually changed the viscosity of the water itself. It was weird.
Yeah. Thicker?
Well, lighter.
Lighter, okay.
So the water that went in at the bottom was like kind of untreated water, but like when we poured the water that was more treated into it, it started like floating on it almost. And then, you know how like a ball kind of rolls around on the surface of the water before it was doing more of that. And we have B-roll to show it too.
Yeah, we'll
it's
do
crazy.
That. Okay, so this is great. This discussion is wonderful, and I'm going to kind of give us another advancing step, because there's a little bit of taking it to the future, and our book covers, we've covered a fair amount of the basis of the story, so much more detail in there. There's really, a lot more to go into and it's a good read. Both versions 1 and 2. And
Well, it also gives you like detailed like analysis, electron microscope images, and like EDS, EDM. Like it's basically like, it's kind of like a story, but it's also a research paper too. It's kind of a combination plate.
Yeah. And what would you call it in terms of academic level? Is this high school, wrten for high school?
Oh yeah, we dumbed it down to high school level.
You enhanced it for readership.
I'm sorry. I apologize.
Okay.
Yeah. It's and that is a good discussion too, is that like, why is it so hard to talk about nuclear fusion to normal people?
Yeah.
And that boundary layer between like the academic people versus normal people, that's like a wall. It's like a curtain that they hold out in front. Like, I don't want you to be here because I want to be in control.
Yeah. Would you say this is then useful to classrooms as well as casual readers?
Yeah, this is written so well by Riley that it's just like, honestly, it's such an easy read. It's so basically good. And the thing too is, if the more you read it, here's what's funny: the more you read it, the more you catch new things that you didn't. It's like a movie,
right? You see the movie a second and third times. There's details you missed. So this is the story part is very good. The integration of the science and technology is also very good to make it blend in so that you understand a clear picture now, not just he went there and he did that. He went there, did this. Here's how, and then
in between too. Like I remember, truth is stranger than fiction. This journey has been wild. So like, we'll go from one study to the next, but there are things that happen in between. Like I'll just give you a little teaser. There was a homeless person that came up to us and talked to us about our technology, and we're like, how do you even know about that?
This is
like, I didn't even. Just a homeless person came up, was like, oh yeah, I know about that. Like, what? So you check it out in the book. It's really interesting.
Yeah, he had a few. I really enjoyed that part also. That's the Astoria fellow.
Yeah. Right.
All right. So this is a great segue, because I want to take this now to the next section of discussion. It might be a little bit present and it might be a little bit future, but let's talk about the David and Goliath without mentioning any names, but dropping the spoiler alert. If you know the biblical story, it does not go well for Goliath, and we're kind of the David with a slingshot against Goliath with a massive spear and full armor. All it took for David was faith and the backing of God, and and I'll just say that. But the point of the story is, this is a little guy that had no fear because of his beliefs that he was doing what he was supposed to do, and went out and slayed the big giant. And this is a little bit of our story too. Yeah. And I want to, again, how comfortable do you feel talking about that? We can't really get into details of it, but we're walking this story right now.
So we are walking the hero's journey to a level that has never been done, maybe in probably 2,000 years. Okay. And every big evolutionary jump in society of like the human race has to go through these tribulations and has to be basically put to the test. And if you pass, you pass, and you get to go to the next stage. If you fail, guess what? Never ending story. Try again. So you're right. We are definitely the David of this story, and there are Goliaths out there. There's not just one.
Right.
And we're trying to do the best we can to get this technology, which is going to heal you. It's going to heal your planet. It's going to heal your water. It's going to make the fish come back stronger. It's going to make the whales happy. And by the way, the whales, I guess, have stopped singing in the ocean. They're all alarmed by that. It's a new study. So the Earth is kind of straining right now. Yeah. And we need to do something quickly.
Okay. So that I penned in this for our last bit of discussion before we get to the close. But how comfortable do you feel about talking about some of the recent discoveries that we've been working with to refine and prepare for production? I've got the words written right there. Are you good?
Yeah, I'm good. What I'll say is this: it kind of ties back to the middle of the podcast about that word that I saw.
Yeah.
And then the guy was like, "Oh my gosh, you can do that." So we did a based on that word that we saw, we did a flow cytometry test on source water.
Could you tell us first a breakdown quick for high school level of flow cytometry?
Correct. So flow cytometry is basically like a really new apparatus of technology that can detect DNA, RNA, different strains of bacteria and stuff like that. It's got a super high fidelity level. So you can like, whatever's going in, you can tell what it is.
And the material is water?
It's a combination. What it does, it goes through a cylinder that has like a laser, I guess, goes through and like checks the fluorescence and has a high fidelity. And so when you
is that like a spectrometer of sorts?
Yeah, it's kind of like that, but it's a lot more. It gives you like a histogram, gives you a curve to see what it could be, and that curve is basically there's all these identifications like, oh, that's RNA, that's DNA, that's whatever.
Yeah.
And so essentially we're like that word that guy was like after and that we could do, we basically alarmingly found out that when you do a safe cold nuclear fusion gravitational flux that's soft, not aggressive, but soft, that we were seeing we saw 4 things, but I'm only going to say 2. We saw DNA levels go up exponentially, and we saw RNA levels go up. So what we basically understand from this, ladies and gentlemen, is that when you do safe cold nuclear fusion, you literally are going from inorganic chemistry, water, calcium, potassium in the water, magnesium, all these inorganic things. And then when you turn it on, it starts to transition to carbon, nitrogen, oxygen, glucose, or ATP, and all these organic things start showing up, like layering, biofilm layering. Like, so all these weird things seem to be stimulated. Oops, there goes stimulated like my mic. Stimulated by this flux that we're able to create with the quantum kinetic well technology.
So back to the carbon that we found earlier on the electrodes and
Yes.
in those. That also was a similar experience. It was a higher power that we were using. But it still has an output that resembles building blocks again.
Yes.
So is this our common thread? Regardless, our technology does this, whatever our application is.
And that's the kind of the cool thing about this technology. It's only limited to the imagination you put it to work. So it can, if you want to do radioactive waste remediation, just throw radioactive waste in it and it figures it out.
Mm-hmm.
You want to do propulsion. Okay, well, we'll get some hydrogen out of that. And I don't know if you want to go into the metal things that are useful.
I did, because remember I told you I wanted to hold a little piece in my hand.
Oh, shoot. Yeah, I forgot to get that little sample ready for you. But we'll throw it up in B-roll. It's literally right next to your head, but you have to like reach over and get it.
Yeah, no, we'll just B-roll.
So actually, some of our investors are actually curious about this material too. It's like, what is it used for?
Well, I started out an investor. I'm still an investor, and believe me, I've got some really interesting views from seeing results now. I'm glad I have a co-pilot seat on all of this because
you're doing great.
Way better than the front row, I can tell you that. And it's really cool to see. We just did. Can I talk about the demo that we just did?
Yeah.
So we have a high density carbon hydride.
Right.
And so what we did was we took a butane torch and lit it up to pretty intense blue flame and set a tray full of this hydride material off and out in front of us, and then blasted it with this butane, and it scattered bright yellow flame. And of course,
that's
we
hydrogen.
know that we're off-gassing hydrogen.
Huge amounts of hydrogen.
Huge amount. So get this, though. Here's the kicker. We get done with doing this for, I don't know, half a minute, and we're like, cool, this kind of thing. And then we stop, and it's like, it
hasn't disintegrated.
It hasn't hardly.
It's a rock.
It's still like, it looks a little bit like there's a black outer crust to it, but it looks basically like it did. The density of this is phenomenal. The amount of hydrogen packed into this with a carbon base.
Yep.
McKane, this is the stuff that puts rockets into space and takes people to the moon and Mars.
Yes.
And we know that 6.7, I believe, is the value you're looking to attain.
Yeah. So the Department of Energy, they're really into these hydride discs. And so what they do is they take that powder and they compress it. So it's like aluminum hydride powder or like magnesium powder or
like
iron.
A puck of some
kind. It's a puck, right? Yeah. And so they squeeze it and they get these pucks. And the cool thing about a hydride is kind of like, it's kind of like a flower, like a dandelion.
Yeah.
It has, when you blow on it and you make it warm, all the hydrogen flies off of it like the seeds. And so these pucks that the Department of Energy makes, they don't know how, the one thing they don't know how to do is make a carbon-based hydride, because carbon is a hexagon shape and it holds hydrogens like the flower, like it holds so much pollen,
right,
ready to release because of the shape of the atomic structures. And so we have found out that we are basically doing what the Department of Energy needs and what everyone needs for a whole new industry of batteries. Oops, this thing is loose. Batteries, and also,
tighten your nut.
You know what's funny about a nut? It's also hexagon. And so hexagons are really important for, space travel. They're really important for hydrides, for batteries. Hexagon shapes, even graphene, these shapes are turning out to be like basically quantum tools that are really awesome.
So we had the results back from our flow cytometry. Mm-hmm. We understood what we were making. And let me ask you this just flat out. Does anybody else have carbon-based hydrides that we know of?
In order to make, just for the audience, the only way to make a hydride really is with a particle accelerator. And these things are huge. Like cyclotrons are huge. They're very powerful and they take a lot of energy to make this stuff. And you can make a hydride with electrochemical stuff, but it's very dirty.
I did read up on that. Yeah.
So it's not preferable and doesn't yield very much. So the best way to make, what's funny is water is a hydride too, right?
Because of the bonding of oxygen with two
hydrogens,
right?
So when you drink, actually it's funny, when you drink water, like when you're thirsty, you're technically drinking rocket fuel because the oxygen's 1 and the hydrogen's 2. That is the stoichiometric ratio of a rocket engine.
Mm-hmm. So how does it look when we can bond this many hydrogen to each of the molecules and heat it up? Off go those dandelion seeds, and we're not destroying this puck that we've created, or this material we've created. So can we?
It recycles really well. Like you could even charge it with, like if you put that sediment in a battery,
mm-hmm.
it actually is better than lithium ion batteries. We can mine the ocean for battery material and hydrogen oxygen material, basically literally with solar panels.
So the science that are now validating as well will create this
a new industry.
And so nuclear waste remediation, would you like to clean the planet up and get rid of the nuclear waste?
Yeah, I would.
And would you like to see the potential for fuel sources? And we can't talk about all that we can do, but there's more besides these.
I would like to see that.
I want that too. And does it burn clean, by the way?
Yes, it does. Oh, actually, when we did the butane torch, when it's on, it actually makes a whole bunch of water. It makes a water pool next to the sediment.
And it's pure?
Well, yeah, it's
more or
less pure because the water pool actually like kind of gloms around the sediment. And so then the sediment kind of rolls into the water, but you can see it on the B-roll. But the carbon that's holding those hydrogen ions, that metal hydride, it's technically a quantum crystal or a time crystal.
Yeah.
It's freezing energy for you.
Can I ask the big question?
Sure.
Who wants to get in? Who wants to do carbon hydrides? Who wants to do fuel sources that are alternatives that we're working on that we'll talk about in the future? Who wants to do nuclear waste remediation? Come knock on our door. Let's get to work.
You can do anything with this technology. And remember, just to put a bow on this episode and close up, but like nuclear fusion, when you do fusion, you're doing love. Love is fusion and fusion is love. You don't have to force it. It just happens. And when you do and you figure out nuclear fusion and you start using it with good intentions, the whole universe gets better for you. It's like this beautiful carpet becomes clear.
Yeah.
And all you have to do is walk it and stay on the carpet and don't fall off.
Yeah.
And you can go to places that you've never even thought of.
All right.
So again, thanks Randall for coming along for this amazing journey.
One more bit. Let's have a sip. That is very good. So season 2, episode 5, we're going to bring back Jason MacCoy. McKane, what's happening in that episode? You guys take us through some of the progression of a couple of your episodes, and now what's new? What are we going to see?
So we're going to be talking about basically how the biology of the universe, like your inner ear, can take a sound wave and turn it into electrical chemical signal for your brain to understand what it's seeing. So basically, photon waves, hertz, gets turned into electron for your brain. And by the way, with the arc reactor, we do the other way. We suck in electrons and we make electricity, okay?
We suck.
Well, no, we suck in a good way.
In a good way.
But yeah, so essentially that episode's going to be wonderful. Jason and I prepared for that really well, and we're super excited to show you guys.
I can't wait to, because Jason is a fun guy.
Yes.
I like Jason a lot, and his episodes are well received as well. So again, thanks everybody.
Yeah.
Almost 300,000 of you are on board with this, and we're looking forward to a very bright future. We have the goods. Come knock on our door.
And be sure to check out the book as well on eBay or Amazon or whatever. It's Barnes and Noble. You won't be disappointed. It's a great read, and everyone should check it out, because if you check it out and then you see our documentary in November, it's going to make total sense.
Oh yeah, the documentary is coming as well. This is a little bit of a preface, but the documentary is going to be the biggest thing.
Awesome.
And we can't wait. Riley is writing Chronicle number 3 right now. And as I mentioned at the top of the broadcast, the story just writes itself, McKane. And it's so much fun to be on this journey and be on it with you. And thank you for
and thank you everyone
me in.
And thank you everyone for coming in and subscribing and following and being a part of it too, because this is a global movement. Like, it's here. If you guys want it, you got to get behind it, and this is the best way you can. So make sure you like, share, subscribe, tell your friends. Let's go. Like, be loud, be proud, and let's go.
All right. Thanks, everybody, and take care. We'll see you again with Jason MacCoy next episode.
Thanks for coming on, brother.
All right. Bye-bye.
Take care.